How do mathematicians solve addition and subtraction problems using place value? Over the past few weeks, we've been discussing different strategies to solve addition and subtraction problems in the 2-digit and 3-digit numbers. Today, we're going to use the same strategies to solve subtraction problems within 1,000. Let's remind ourselves about place value. This number is 1,234. But each number here is not one digit. For example, the 4 is in the ones place. The 3 is in the tens place. This means that this is not a 3, but it's actually the 3 representing a 30, or 3 tens. The 2 is in the 100s place, so it is not representing 2, but it's actually representing 2 hundreds, because it is in the hundreds place. And this 1 here is not just a 1, but is a 1,000, because it is in the thousands place. Let's remind ourselves what we learned the past week or so in the different strategies to solve 3-digit subtraction problems. We've used T-charts, where we've used a box to represent 100, a 10 stick to represent the tens, and a dot to represent the ones. For subtraction, you draw pictures for the first number, and then use the actual numbers to put in the second number that you're subtracting. With subtraction, you always put the larger number first, and then take away the smaller number. For 234 minus 165, we put 2 hundreds, 3 tens, and 4 ones, and then we put 165 below to subtract. Because there was not enough ones to take away 5, we had to break apart a 10, put the tens over here in the ones place, and then we were able to subtract 5, and we ended up with 1, 2, 3, 4, 5, 6, 7, 8, 9. We wrote 9 down here. The next column, for the tens, we weren't able to subtract 6. So we had to break apart the hundreds, take 100s, a 100 block, break it apart into tens, or 10 tens, which is the same as 100, in order to take away the 6. And we came up with 6 tens. When we went to subtract the 100, the 100 was already, this 100 was already taken away, and so we subtracted it from the 100 left over, and we were left with 0 100s. Using the standard algorithm, we use the same method in having to break apart the tens and then the 100s in order to give us enough to subtract the bottom number. And then expanded, you break apart or decompose, which means break apart the larger number into parts to represent the number. So 234 became 200 plus 30 plus 4. The 165 became 100 plus 60 plus 5. And then we were able to subtract the numbers by borrowing the tens and putting them over in the ones, and the 100s and putting them in the tens to subtract. This is a review of what we learned over the past couple weeks. Now we're going to talk about some strategies to subtract from 1,000. The subtraction problem we're going to use is 1,000 minus 472 equals x. This first problem we're going to use a T-chart. Now, we know when we're subtracting from the 100s, we would have a dot for the ones, a stick for the tens, a box for the hundreds, but for this problem, we're also subtracting out of 1,000. So for the thousands, you can make a thousands block like that, or if that's a little hard, you can also do a block with a T in it to represent 1,000. Okay, so the number we're subtracting from is 1,000. Now, remember, for subtraction problems, you are putting the larger number on top in place value blocks or pictures, and the bottom number you're writing in numbers. So the first number is 1,000. We're subtracting this number from that number. So for 1,000, we have 1,000 in the thousands place. We have 0 hundreds, 0 tens, 0 ones. So I don't have anything to put there. So I go to the next number. I'm going to be subtracting 472. There's no thousands, so I go over to the hundreds. I put the 4 in the hundreds place because it's 400, the 7 in the tens place because there's 7 tens or 70, and the 2 in the ones place. I draw a line and I'm ready to subtract. Oops. Okay, subtracting 2. Well, there's no ones for me to subtract from. But there's also no tens places or tens or 100s to subtract from 1,000 either. So I'm going to have to go all the way over to the thousands and break this apart. Now, if there was a number here that I could subtract from and break it apart to move it over to borrow, I would do that here or here first. But because there's no other numbers here, I have to go over to the thousands. I'm going to break apart the thousands, and I'm going to put this over into the 100s column. Now, 10 hundreds is the same as 1,000. So if I break apart a thousands block, that's going to be 10 hundreds blocks. 5, 6, 7, 8, 9, 10. All right, now, I still don't have those ones to subtract that 2 from, so I have to continue breaking apart these numbers and putting them into the place value below. So I'm going to take this away and put it in the tens place. So I broke apart a 100 block and put it into the tens. 10 tens equals 100. So this becomes 10 sticks. Okay, I'm getting closer, but now there's still not anything for me to subtract that 2 from. So I'm going to have to break apart one more 10, put it into the ones, and 10 ones equals a 10 stick. All right, now I'm able to subtract away 2 from these 10 ones. 1, 2, and I'm left with 1, 2, 3, 4, 5, 6, 7, 8. All right, now I'm going to move over to the tens. 7, I'm able to take away 7 from 9 because I have 9 10 sticks left, because remember I borrowed that 10 and put it over there, so that's no longer there. So I'm going to take away 7 tens. 1, 2, 3, 4, 5, 6, 7, and again I'm left with 2 tens, which is the same as 20. Now I'm going to subtract 4 from the hundreds. 1, 2, 3, 4, and I'm left with 5 hundreds blocks, which is 500. Now, I don't have a number here to subtract from the thousands, and the thousands has already been broken apart, so my answer is 528, or x equals 528. All right, so that is one strategy. Now we're going to take a look at the same problem, but using the expanded or decomposed way of solving the problem. This is going to be a great way for us to check our answer and see if our T-chart got us the right answer. So 1,000 broken apart is 1,000 plus 0 hundreds plus 0 tens plus 0 ones. Because we're looking at the place value here, and we're seeing that there's a 1,000, 0 hundreds, 0 tens, and 0 ones. Now, we're going to be subtracting. We don't have any thousands here, but we do have 400 plus 70 plus 2 equals 472. So this is what we're going to be subtracting here. Now, we're not able to subtract 2 from 0, so we're going to have to move over. Oh, we can't take it away from that 0 to borrow and break apart, so we're going to come over here. There's nothing in the hundreds place of this number to break apart, so we're going to go over to the 1,000, and we can break this apart. Now, we're going to break that apart. We're going to take it away, and it becomes 0 because we're going to add it over to the hundreds. Now, this becomes 1,000. Now we're able to break this apart to become 900, and this is going to become 100. All right, now we are going to have to borrow from here. This is going to become 90, and we're going to put the 10 over here, and this becomes 10. Now I'm going to take 2 away from 10, which is 8. I'm able to take away 70 from 90, which is 20. Now remember, we're still going to be adding these numbers together at the bottom. And then taking away 400 from 900 is going to be 500. I then add these three numbers up, and that becomes 528. All right, so we're going to look at our last strategy, which is going to be standard algorithm. For the standard algorithm, we put 1,000 on top, and we write 472 below that. We're going to be subtracting. Now, just like the two strategies before, we are not able to subtract 2 from 0. But we're also not able to borrow anything from the tens place or the 100s place because they're both 0. Because of that, we go to the thousands place, and we put that over here. Now, this now becomes 10, or 10 hundreds. But we still need to borrow to be able to subtract from the ones in the tens place. We then break apart these 10 100s, and it becomes 9 hundreds. And we move it over the one that we took away and put it in the tens place. So this is now 10 tens, which is also 100. Now we're going to take away 1 10. This becomes 9 tens, and this becomes 10. Now we're able to do the subtraction from the ones place. So we take 2 away from 10, and that becomes 8. We're able to subtract 7 from 9, which becomes 2. We're able to take away 4 from 9, which becomes 5. And we come up with the answer of 528, where x equals 528, which is the same that we got on our T-chart. All right. Now it's your turn. You're going to use these strategies along with the chart that your teacher is going to give you in order to solve some problems on both subtraction and addition within 1,000. You're going to be using the same strategies you use for 3-digit and 2-digit numbers to solve the digits or to solve problems within thousands.